Let's discuss how we can find the average value of a certain function using integrals. So first, let's talk about a function that should be familiar to us. Say we have f of x is equal to sine of x. So we should know how to graph this function. Let's draw our x-axis and y-axis. We'll do it to the side this time so we don't take much room, because we're going to talk about the average value of this function on the same page. So we'll graph this function from 0 to 2 pi, because we know this function repeats, right? That's our x, that's our y. We'll say this is 2 pi. We know that at 0, sine of x is 0, and at 2 pi it's 0 as well. And then at pi over 2, it's supposed to be at 1. So this is 1. And then also at pi, it's 0. And then at 3 pi over 2, it's supposed to be at -1. Alright, so that's a few points there. We can sort of graph it now. Let's do the same green color. So it starts at 0, does something like this, and then it goes back to 0. So that's sort of how a sine function looks like. So we'll say this is sine of x. Now, let's say we want to find the average value of this function from 0 to 2 pi. And what I mean by that is the average y coordinate of this function, or the average value of this function from 0 to 2 pi. And before doing any math, we should actually just look at this intuitively and see if we can figure it out. Well, from 0 to pi, it looks like the average would be somewhere around here, right? And from pi to 2 pi, it looks like the average would be somewhere around here. And these two numbers are actually the same. Their absolute value is the same, but this one is a positive number, this one is a negative number. And if you take the average of those two, because we're taking the average from 0 to 2 pi, then the average would just be 0. So the average value of the sine function from 0 to 2 pi, or in one period, is just 0. Now let me show you the average theorem, or average value theorem for integrals, and we'll confirm that we get 0. So this right here is the formula. The integral, actually, let's say, the average value of f of x, I'll just denote it like this, is equal to the integral, actually, we'll do it like this, 1 over b minus a times the integral from a to b of f of x dx. So in this case, our a value would be 0, right, because we start at 0. And our b value would be 2 pi, because we end at 2 pi. So let's use this function and see if we get 0. So this should be equal to, in our example, 1 over 2 pi, right, because 2 pi minus 0 is 2 pi, times the integral from 0 to 2 pi of sine of x dx. Well, the integral of sine of x, we can use our trig derivatives and think of it as a function such that its derivative is sine of x. And that function should be negative cosine of x. And if you didn't quite get that, I encourage you to watch our videos on trig derivatives and also anti-power rule. Alright, so it's going to be 1 over 2 pi times the negative cosine of x from 0 to 2 pi. And again, the derivative of cosine of x is negative sine of x, so the derivative of negative cosine of x is sine of x. So this integral is correct. Now let's evaluate it from our the bounds that we have. So this is equal to 1 over 2 pi times negative cosine of 2 pi minus, and this is going to be 1 over 2 pi times the whole thing, minus negative cosine of 0. Alright, let's evaluate it. So inside we have negative cosine of 2 pi, that's -1, because cosine of 2 pi is 1. So we have 1 over 2 pi times -1 minus negative cosine of 0. So cosine of 0 is again 1. Negative that is negative 1. So minus negative 1. And this is equal to 1 over 2 pi times, well, negative 1 minus negative 1. That's just negative 1 plus 1, which is just 0. 0 times 1 over 2 pi, that's just 0. So the average value of this function from 0 to 2 pi is 0.